Welcome to Calc 13. Today we're going to be talking about the derivative at a tangent line and average rate of change. Early on last quarter we talked about tangent versus secant lines. And so we said a tangent line was the slope at one point on a curve, and then the secant line was the slope between 2 points. So if I'm looking at just kind of a basic parabola, our tangent line would hit the curve at 1 point, and that would be the slope at 1 point, versus a secant line would go through 2 points. So here I'm trying to find the average rate of change. And so average rate of change, we think about averages, it involves more than one point, one number. And so in order to find our average rate of change, we need to use our secant line. And so if we think back to Algebra 1, our slope is equal to our y2 minus y1 over x2 minus x1. So this is pretty much all we're going to be doing in order to find our average rate of change. So I'm looking on the interval from 1 to 3. So those are going to be my two kind of endpoints. So I'm going to find first f of 1 and f of 3. And so for f of 1, I get that that's 0, 1 minus 1 is 0, and for f of 3, I get that's 24. So when I find my slope is going to be y2, so f of 3, 24, minus 0 over my x's. Remember, my interval was 3 to 1, 3 minus 1. So my slope is going to be 24 over 2, and my slope is 12. So that is the average rate of change on that interval. So now we're looking for the equation of the tangent line. And we have a few new vocab words, actually just one. So tangent line, we already know what that means. It's the derivative, it touches the slope or the curve at 1 point. And then normal, so normal is our new word, and this basically means perpendicular. So I want to find this equation for the tangent line. So this is kind of our parallel slope. And then I need to find my perpendicular line as well. And so we actually know how to find the slope. So our slope of the tangent line is our derivative. So if I'm looking at the derivative of f of x, I get that my derivative is negative 2x. So my derivative at the point x equals 1 is just going to be negative 2. Negative 2 times 1 is negative 2. So that is my slope of my tangent line. So this is tangent. And then my normal, if you remember perpendicular, we take the opposite reciprocal. So our reciprocal would be negative 1 over 2, and then our opposite would be 1/2, so this is our normal slope. So I have my two slopes. That was the first step. And then now I need the equation of a line. So if we remember, again, from Algebra 1, y1 minus, or y minus y1 equals m x minus x1. This is our point slope formula. And so we have our slope, and then we're looking at x equals 1. So my x is 1. So to find my y value that's associated with that, I'm going to plug in 1 to my original formula to get 3. So the slope I'm looking at is 1, 3. Or sorry, the point I'm looking at is 1, 3. My slope is negative 2 for my tangent line. So I'm going to find the equation of my tangent line first. So I'm just going to take y minus 3 equals negative 2 x minus 1. And then I'm going to take y minus 3 equals negative 2x plus 2. Add 3 to both sides. Y equals negative 2x plus 5. So this is my equation of my tangent line. So since we're dealing with the same point for our normal line, we can just plug in y minus 3 equals, and then we set our normal, our slope that was normal to the curve was 1/2. So I'm just going to plug that in for m equals 1/2 x minus 1. So I get y minus 3 equals 1/2 x minus 1/2 plus 3 plus 3y equals 1/2 x, and then we get plus 2.5, or 1/2 x plus 5/2. So this is our normal line, our equation of the normal line. So this is it for instantaneous rate of change and equations of tangent and normal lines. Please come to class with any questions you may have, and like and subscribe. Thanks for watching.